Welcome to another video on my ESP32. An embedded system, Internet of Things, lots of options to attach to. In my case, LED, buzzer, sensor command display, which are actually 7 LEDs, microphone, light dependent resistor, LCD, fischertechnik motor, pulse modulation driven, and a servo motor, also pulse modulation driven. Objective, focus of this video is once again to get something out of this microphone. And by the 4 probes you can see that the oscilloscope is attached to capture some, or to visualize some signals. Last time I have found some odd behavior, odd things, so let's hope to clarify them this time. So let's see how it behaves this time. And this is then of course the computer view using Fedora Linux with Arduino environment, serial terminal, serial monitor as it is called, and well, the hardware and the oscilloscope. Setting it up properly again. Set to 5 volts, and hopefully it does work. It shows off. And one thing to start with is that I added here a very small LED, because last time this LED, the big one, didn't do anything, didn't show anything. Anyway, let's start by uploading the program. And if you haven't seen my previous videos, I have to use AVR or Arduino C because this is the Arduino environment, and I'm using random access memory on the ESP32. In previous videos I have also used the flash memory, in which case I can use Ritchie C or NCC, standard C, whatever you name it. Anyway, let's go. Right to RAM, and there you go. One thing that I should mention is that it was very odd that from the beginning these 2 signals coming from the digital output were high from the very first time. And that's odd, very odd. This is analog output and output to the yellow LED and the little green one. So how can this, without any program running? Oh, this is the idea to force any action. Let me stop ticking. Then the signal should go down, which it obviously does not do really. Now it goes down. Oh, that's an interesting one. It looks like it responds to the beeping. Let me, although I have put the microphone, or the buzzer actually, in here, and the microphone responds to the buzzer. So I should actually do something different, which is disabling the buzzer. Let's do that. And there were 3 instances of a buzzer right here. So let's upload. And then the buzzer should stop. Hard resetting. Oh, and the motor starts to run. Which is then the fischertechnik motor and not the servo motor. But nice effect, but that's not the focus of today. Once again, there are now no signals, but still the output is high, which is very strange. So this should force an output on both both blue lines, and quite obviously that is not really what's happening. Oh, I see why the servo motor doesn't work, most likely. With the wire out. But then again, anyway, that's not the focus. The microphone is the focus, and it still doesn't do a thing. It's set to 5 volts. And then I find it very strange that both LEDs are not doing anything, which while there is signal, it needs generally some 2 volts or 2.5 volts to blink. And if I look at this red LED right here, from the camera you can't see it properly, but it is burning, and that is this line, the dark blue line. And if I take it off, then you see it respond. So that is 3 volts, 2.5, 3 volts, 2.5 more, yeah. Still mystery. So if I do this, I should be seeing lots of signals. Now nothing. Yeah. Okay, it has some delay, but not that big. Doesn't respond to my voice. The only thing that I have a problem with in that case is the oscilloscope shows it right away from the probes to the oscilloscope, not via USB cable to the laptop. So if there's a delay to the oscilloscope, then there's an even bigger delay right here. So something is not quite as I expect. A new idea, I have put the type of signal on the oscilloscope from pattern to edge with a response to an upgoing slope. So when I give a signal, what happens with delay? Which can be because it has to be detected by the microphone, sent to the ESP, then responded to both LEDs, no matter if it is analog or digital. It has a response time. So there is a possible delay. How much delay, I don't know. Strange thing is though that the both LEDs here are not responding anything. This one is off currently. So the digital one is not doing anything. That may be due to my program, by the way, because I'm not doing a digital output. But the delay may very well be caused by this whole circuit. Although it's a delay in seconds then, and not in milliseconds, which I would have expected. It's now complete quiet. If that was voice, it is to be explained. But then again, why is this absolutely quiet? That is not, I cannot explain. There's nothing here. It's output from the microphone. This is direct output. This is direct output. So still things I cannot explain. Maybe better, maybe not. Result, I mean. But it remains strange. As is the toothed type of the signal. So, focusing on the analog output, it's weird, in my opinion. So, taking a look at the schematics, microphone with digital output to port 14 and 27, mostly 14, and analog output to port 12, giving output to 13 and 9, yellow and by now also green, and the red one. So digital, digital, analog, analog. and what to make of it. Yeah, well, that's for next time then. So, although the algorithm has changed a little bit with regard to the buzzer, the question is not being resolved. So, the oscilloscope still gives only some signal on the output from the ESP32, and that's all it does. So for now, thanks for watching. If you like this video anyway, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, much appreciated. You can also follow me via Instagram and Twitter. You can support my blog by becoming a patron and have your name mentioned, or becoming a co-producer. For more information, see on my website, which is listed under this video, or if you wait the final segment of this video with all the information. You can also make a donation via PayPal or via IBAN. This is going to be continued. Stay safe, have a nice day, bye bye.